Today, our whole world mostly is powered by about 80% combustion energy. And that's 100% combustion energy when we talk about flight. And all of those fuels have traditionally been fossil fuels, fuels we take from the ground, fuels that contain a lot of carbon in their structure. That contributes largely to climate change, which is, in my opinion, the biggest issue of our time. If we want to take this 80% of energy and 100% of flight and make it into zero carbon and low carbon, the best way to do that is to change the fuel. So what my lab does here in the Faculty of Aerospace Engineering at Technion is we look into different types of fuels which can change the impact on the environment. We can use a fuel that doesn't contain carbon within its molecular structure. For example, hydrogen or ammonia. There are a lot of problems though with where do you get the hydrogen? Where do you get the ammonia? How do you produce it? But then how do you burn it? How do you transition from these fossil fuels that are liquid at room temperature, that are easy to store, to something like hydrogen, which you need to store at really high pressures, or something like ammonia, which is actually a toxic gas and doesn't burn very well. But we need to do these things, and we need to develop the science on how our engines can work on these fuels, and our group is contributing on how to work with them. The other large focus area of my group is supersonic combustion, or scramjet combustion. We try to ignite the engine, and you have to ignite the engine when it's already traveling at supersonic speeds. So it's like trying to light a match when you have hurricane force winds coming at you, but the hurricane is a supersonic hurricane. How do you ignite that? So that's something we look at, and we're using plasma in order to ignite it. Very, very, very high temperature, thousands of degrees gas in order to ignite that. This is ignition tunnel, our plasma ignition tunnel. And a lot of what we're doing here is to look at ammonia and how ammonia ignites in a flowing mixture. So this isn't something that's been explored before. We have this high-speed camera which can take images at up to 2 million frames per second. And at the same time, we take high-speed imaging with 2 infrared cameras, one there and one mounted on top. And so that gives us a lot of tools to make a really nice picture of what's going on with the ignition event and allow us to develop technologies based on that. Another thing we do is diagnostics. Where's the fuel going? How is it mixing? Is the combustion efficient? The hyperspectral camera is a really unique device, and it allows us to take a spectra on every single pixel in the infrared range. And then in this flame, I will get an image where on each pixel, I'll have the entire spectra, which I can extract temperature data, concentration data of all the species, all in one picture. So a lot of these questions are central to being able to have this very high supersonic flight, which can be used for space entry, which can be used for really high-speed transportation. If you want to go to New York to Australia in 2 hours, you could use these types of jet engines. But they just don't exist yet, so we're trying to develop those technologies. So what the Zuckerman Institute allowed us to do is build a lab that we can handle these types of experiments in. The lab in this room here is just a small portion of the breathing thing that a combustion lab needs to be in order to do even simple experiments or larger experiments where we have toxic gases, where we have flammable gases, where we have gas emissions, where we have high pressures. All of these things are very complex, and with Zuckerman's donation, we were able to build a lab where we can safely do this research on the cutting edge of green energy. What we really would like to accomplish in the long run is suggestions on how to build an engine, and even creating engine prototypes for using ammonia. And by creating such an engine and burning environment, we could very easily transition all of the energy infrastructure we have related to powering gas turbines and jet engines to this completely zero carbon fuel. And this would be a major accomplishment, and we hope to participate as much as we can in making this a reality.